Class, our today's new topic is flotation and sinking. So try to understand what is flotation and what is sinking. So with the help of cork we can understand this. Class, this is cork, and if I am talking about iron piece, this is your iron piece, then it will sink in the water. So why cork is floating in the water while iron is sinking? Because class, density of cork is less than density of water. So density of cork is less than density of water, so it will float, while the density of iron is more than density of water, so it will sink. So class, your flotation and sinking is all depends on density. If density is less than density of water of that particular object, then it will float, and if the density is more than density of water, then it will sink. So this is the basic principle of flotation and sinking. So when a body is immersed in a liquid, the following two forces acts on it. Number first force is weight of the body, which acts downwards, because you all know class, weight always acts downward just because of the gravitational pull. So weight of the body acts downwards. And number second force is buoyant force, which acts upwards. Now you have a question, what is buoyant force? So class, it's very simple. If I am talking about this object, so what is buoyant force? This object displaced some water, because here you can see here class, the very big amount of water is here, but we are not going with that. We only concentrate on that water which is displaced by this object. So how much displaced water is here? Displaced water. This is the displaced water by this object. So we have to only concentrate on that displaced water. So the buoyant force is equal to the weight of the liquid. Weight of the liquid which is displaced by object. It means we only concentrate on the weight of this displaced water or displaced liquid by this object. So weight of the liquid which is displaced by the object. So your buoyant force is actually equal to the weight of this displaced liquid class. So this force has a tendency to move the body upwards. This is why buoyant force is also called upthrust. What we call that? Upthrust. Because class, upthrust acts in the upside. It means the force which acts upward, we can say that is upthrust, and that is equal to the displaced water or displaced liquid. So there are three important conditions or cases are here. So we will study those cases. Number first case is when the weight of the body, which is known as W, is greater than the buoyant force. Here I just write buoyant force as force B. B means buoyant force. So class, it means your W is greater than buoyant force. It means your weight of body is greater than buoyant force. So what will happen in this condition? If class you have water and this is your object, and if your W is more than buoyant force, so class, if W is more than FB, then definitely this object will sink. Yes or no class? Because W is working downwards while your FB works upwards. But because it is more than this, so definitely it will go downwards. So now class, it's very important when this condition will arise. this condition will arise only when your density of object is more than the density of water. So if your density of object is more than the density of water or density of liquid, then at that time your W is greater than buoyant force. Now class, second case is the weight of the body W is equal to the buoyant force. It means W equal to Fp. Now class, now you understand W means density of body is equal to the density of liquid. So when both the density are equal, at that time what will happen? Suppose this is your surface of water. So at that time your object is floating but just below the surface. Here your W and Fv are working in this condition, but both are equal, W equal to Fv. The meaning is the density of body is equal to the upthrust force, or we can say the density of body is equal to the density of liquid. So at that time if both have a same kind of force, so you have to understand here the resultant force of the body is 0 and the apparent weight of the body is 0. So the body float just inside the surface of the liquid. And this is case third class, when the weight of the body W is less than buoyant force. It means when W is less than Fv. So what is the meaning of that class? In this time W means density of that particular object, is less than the buoyant force. It means in this time your buoyant force is more than the density of this object. So in this case class, the resultant force acts on the body upwards. That's why it will float. In this time your Fv is more than W. So at that time your body will float. Class, our new topic is law of flotation. When a body floats in a liquid, the weight of the liquid displaced by its immersed part is equal to the total weight of the body. This is the law of flotation. So what is the law of flotation class? Weight of the floating body equal to weight of the liquid displaced by its immersed part. What is the meaning of that class? Your law is weight of the floating body equal to weight of the liquid displaced by its immersed part. Whose immersed part? The body's immersed part. So class, you can see this is the water level. So class, in this body this is the immersed part and definitely it will displaced some water from here. So that water is very important for floating, because the weight of the liquid displaced by this immersed part, weight of this water is equal to the total weight of this body. This is the law of flotation. Now if I am talking about activity, suppose you have water here and glycerine, and now you all know whose density is more, water or glycerine. You all know the density of glycerine is more than water. So suppose we have a wood box. This is the wood box. So we have a same wood box in water also and same wood box in glycerine also. Suppose the weight is remain same. So the weight of this box A and the weight of this box B remain same. So this A also displays some water from here and this B also displays some glycerine from here. So as we all know, in flotation the weight of water is equal to the total weight of this box, and the same here, the displaced glycerine, we have to weight that, and the weight of displaced glycerine equal to the weight of this box. But because the density of glycerine is more than water, so definitely it is heavier than water. It's very simple. So definitely class, if it is heavier, or we can say if the density is high, then it displaced very less. So glycerine is heavier than water, so definitely this box displaced more water and it displaced very less glycerin here, because class, a very less glycerin equal to the high amount of water. So hope it's clear class. Suppose class, the displaced water is here, suppose it's 5 ml, but if I'm talking about glycerin, definitely it is 2 ml. So why it's happened class? Just because it is heavier than water. So in both the condition, you can understand the same object can displace different amount of liquid. It depends on the density of that particular liquid.